Now that we have a basic understanding of how Python works and the features it carries on, let's take a look on how to set up a Python project and especially on how to start with the right foot. Set up correctly the environment, in particular, in which we are going to work, is one of the most efficient and sometimes underrated action you can take when programming. Before starting to code, it's better to understand and set up correctly the environment. So, step 1. We need to select the machine in which we are going to work. Could be a physical machine, a virtual machine. We can use Google Colab, and we will understand in a few slides what Google Colab is. Do we want to let the program run in the cloud? With which operative system? These are some of the questions we have to answer in the step number 1. In the second step, once we have chosen the machine where we want to develop the project, we have to design a specific environment in which we are going to work. And by specific environment, I mean, do we want to build a specific container for this project, a virtual environment? Which Python version will we use? Do we want some pre-installed libraries? These are some of the questions about the second step. In the third one, we focus on creating the folders where we develop the project. And we will use generally standard names. So to select which folders and directory we will use, we have to have in mind what the project is about, what type of data and files we are expecting to work with. And finally, we have to manage a convention or a sort of system, a program that keeps track of the file modifications and the file versioning. For example, do we want to provide the last modification date in the file name or a single version number? Do we want to use Git? These are some of the questions that needs to be answered in the last step when developing the environment in which we will work when coding with Python. So to explain these 4 steps, I want to present you 4 different setups for different stereotypes, we could say. For example, we have the newbie programmer. In here I name newbie. The term newbie is intended as an experienced person. It's not, of course, intended to offend anyone, since everyone started from here, from knowing nothing about Python and learning it by steps. So, not knowing anything about Python, what we would prefer? Well, a newbie programmer is starting to learn Python programming, so he prefers the simplest, ready-to-use tools. For example, he will probably use Windows. Probably he will use the most recent Python version because of the documentation and the compatibility with all the libraries. It will probably develop its first code, its first programs on a main test folder, and that's it. And probably the versioning system will be just the files names will be core content related. That's it. Very simple stuff and easy to use. Another case could be the newbie data scientist. In here we have a person that a newbie that wants to perform some data science wants to analyze data, and in order to do so, it should also learn how to code. So even here, he prefers the simplest, ready-to-use tools. But its desires are a little bit more specific than the newbie programmer. And in a few slides, we will see how we can satisfy these particular requests. For example, the newbie data scientist will use Google Colab, which is a temporary virtual machine that Google let to us for free for 8 hours of a working machine, in which we can code for free using Jupyter Notebooks. Probably using Google Colab, this tool has pre-installed libraries, and all the libraries inside Google Colab are all tied together and compatible. So this facilitates the work. Using Google Colab, you will probably have a main test folder or a Google Drive, where to save files. And again, the file's name will be probably content related. That's it. The third stereotype that I want to present you is the chill guy. What I call chill guy is a guy that knows what to do. He has done some Python projects, and usually is involved in quick and dirty projects. So he also prefers to set a quick and dirty setup that allows him to come to the result as quickly as possible. This means that the chill guy can use Windows or Unix, for example Linux, because he is also, for example, interested in operative systems. So he learned something about Linux. But since he wants a quick and dirty setup, he prefers Anaconda, which is a set of pre-installed libraries and Python. You can find it online. You just have to write on Google Anaconda download Python, and you will find this large executable which will install on your machine Python and some predetermined libraries. Actually, in the full version of Anaconda, those libraries are a lot, are in a big number. The chill guy, since has the quick and dirty concept in his mind, will probably use a main test folder, not a particular setup for its directory. But since he also produces a lot of versions of the files, he prefers to use, yes, content-related file names, but for example, the last modification name at the end of that file name. So he keeps track in the simplest manner the version of the file. Finally, we came to the freelancer, another stereotype, and the freelancer may deal with long and complex enterprise projects. And that's because he needs a scalable and reusable and well-organized working environments. Generally speaking, he could work on a physical machine, could be Unix or also Windows, why not? Or even in the cloud if the project is that big, or maybe the enterprise has a setup, a coding setup in the cloud. as a space where to run the code, for sure a freelancer would use a virtual environment, and we will see in a minute what a virtual environment is, or even a Docker or Kubernetes. Also, since it needs some sort of scalability and the project is complex, he wants to organize the work. So it will divide the main directory in multiple subfolders with standard names. For example, then the folder data, the folder source, where you put the source code, the folder app, if the project involves the development of some sort of app, and so on. And also for versioning the files, since there are a lot of files and a single coding, a few lines of code could have multiple versions, and the freelancer wants to keep track in a very smart way using Git, the Git versioning system. As I promised to you, now I wanted to go in deep with virtual environments. And in particular, a virtual environment consists in a copy of the Python binaries plus some files that allow to use and activate that environment. So it's like a small Python that we can extract in a folder. Why? What are the advantages of virtual environments? Well, they are closed and bounded environment because they stay on a folder, and to have access to the environment you have to activate that environment. You don't have a lot of Python libraries installed in the whole machine, just in the virtual environment. Second point, with virtual environments, you can work with different projects on the same machine, even if they require different versions of the same modules. Why? Because in separate folders you can create multiple virtual environments. Third, you can install Python modules without being the administrator. This is a huge security advantage, because this means that a user does not necessarily need to have the administrator permissions to run Python and to install Python libraries if he needs this. Also, the virtual environment can be created even from the Anaconda installation, but as my experience, they are less efficient, because when creating a virtual environment from Anaconda, Anaconda will automatically import all the default libraries that Anaconda provides in that virtual environment. So now I want to go through the process of set up and install a Python and set up a virtual environment. So the first thing to do is to install Python 3 on the machine. And you can do it by going on python.org, and you can find this button, Download Python. In October 2020, we have the Python 3.9 version. Please do not program with Python 2, because it is not supported anymore. If you can, please program with the latest version of Python. Also to note here, when downloading Python and installing Python, if you are on Windows, for example, from Python 3.4 or later, pip which is a small program, will be included in the Python installation. And pip is the standard package manager for Python. So Python carries on some standard libraries, but what if I want to install other libraries? The pip package allows us to install and manage these additional packages that are not part of the Python standard library. Then we can create a folder for the project and select a name for the virtual environment. Usually the virtual environment is called venv or less commonly env, because in this way the venv folder is immediately can be immediately recognized. Is a sort of standard convention, a naming convention for the virtual environment. To create the virtual environment, we can type python/m venv and the virtual environment name we want. Here I have selected the venv. Then, to operate with the Python version inside the virtual environment, we need to get access inside the virtual environment. In order to do so, we have to activate the venv. To activate the venv, here we are running this batches script on Windows. Also, inside the venv, you can see that after we will perform this in live in a minute, but after activating the virtual environment, you will see this line of code, which will be the name of the virtual environment on the left, and then you can write pip install and the name of the library. For example, this library is called NumPy, and the machine will install the NumPy library. As you can see, successfully installed NumPy 1.19.2 inside the virtual environment. So when I will deactivate the virtual environment and I will check if that library is installed in the Python version inside the machine, the whole machine, I will find nothing. The pure, untouched Python version. The library is inside the virtual environment and only there. That's why I said that the virtual environment are bounded, are closed, and this is a huge advantage. Because, for example, in this project, I could prefer to use, for some reason, the NumPy version 1.19. In another project, in the same Windows machine, I maybe want to use the 1.10 version of NumPy. I can do this thanks to virtual environments. So, in these two lines of code, this one and this one, we have activated and installed activated the virtual environment and installed this particular module. We can install whatever module we want just by running pip install name of the module. As I mentioned before, to activate the environment, we have to run different scripts between Windows and a Unix operative system. On Windows, we will run this batch file that will be inside the venv folder scripts activate bat. On Unix, we have to run source event name bin activate. Another advantage of virtual environments is that we can export the list of libraries we have installed in the virtual environment. Just by typing inside the virtual environment, as you can see here, pip freeze, which is the command. So we are telling to the Python packaging management system that we want to run the command freeze, and that information that you freeze, please save it inside requirements.txt. And opening the requirements.txt, we will find numpy equal and the version of numpy. The exact library and version we have installed in the slide before. This is very useful because if we wanted to create another virtual environment with that specific requirements, now just by carrying on that txt file, we can do it. We can install libraries inside the env, the virtual environment, from a list of requirements. We have just to run inside, this could be another virtual environment. We have to run pip install r, which means requirements, and then we type in the name of the txt file. Finally, when the job is done, we have completed the project or we want to close the machine, we need to deactivate the virtual environment by just typing deactivate.